Right, question 15. OAB is a sector of a circle centre O. OA is 6 centimetres, AX is perpendicular to OB. The area of sector OAB is 6 pi centimetres squared. Show that AX equals 3 root 3. Ooh, fun. Right, so the first thing that we are going to want to find is this angle here. Let's call it X. Okay. For that, we're going to need to use the fact that the area of a sector is 6 pi centimeters squared, and the general formula for the area of a sector is your angle is a fraction out of 360, so we've called our angle X, times by pi r squared equals the area. So I'm just going to write this fraction in a slightly different way, because if we do a fraction times by something, then all of this will become the numerator. So we get x pi. We do know what r is. R is 6 times 6 squared. Divide that all by 360, and that's going to give us our area of 6 pi centimetres squared. Right, at this point, so let's just multiply this out. So we've got, I'm going to change the order of things slightly as well. We've got 36x, or pi x, doesn't really matter, divided by 360 equals 6 pi. Next, I'm going to simplify this fraction as far as I can by dividing through by 360. No, not 336. So we get x pi over, if we divide that by 36 over 10 equals 6 pi. And then if we times by 10, we get x pi equals 60 pi. And then we can take out a factor of pi, divide by pi, x equals 60. So that means that this angle way back up here is 60 degrees. Okay, now we are going to have to show, we are showing that AX, this length here, is 3 root 3. We know that we've got a right angled triangle, then that is one side of the right angled triangle. Let's call that X. Or should we call it A actually, so that we don't get confused. And we know that this is 6, and we know that this is 60 degrees. Now, this is a non-calculator paper, so we're going to have to use exact trig values. First of all, let's work out whether we're using sine, cosine, or tangent. So we've got that this is the hypotenuse and this is the opposite that we want to find. So H we have, O we want. We are going to be using sine. We want to find the opposite, so we are going to be doing sine 60 times by our hypotenuse, which is 6. Now, exact trig value for sine 60, learn it, know it, it's root 3 over 2, which means that that is 6 root 3 over 2, which is 3 root 3. Proved, not proved, shown. Question 16. A, B, C and D are points on the circumference of a circle centre O, and they are making a quadrilateral, a cyclic quadrilateral. Angle BAD is 112 degrees, and angle DCO, sorry that bit there, is 33 degrees. For the first question, part A, show that y equals 35 degrees. So we want to show that that is 35 degrees. What we're going to do first of all is we are going to work out this whole angle here. Okay. So that is angle DCB. And its opposite angle BAD. So it means that it's going to be 180 take away 112 degrees, which is 68 degrees. And the reason for that is opposite angles in a cyclic quadrilateral sum to 180 degrees. Okay. Now, knowing that, we are going to work out this angle here, which is angle BCO, and that's going to be 68 minus 33, which is going to be 35 degrees. And that's the difference between BCD and DCB and DCO. Right, and then the last thing is y equals 35 degrees, because it's an isosceles triangle. So we can now say OCB triangle. OCB is isosceles. And I probably spelled isosceles wrong, I usually do. Right. Then it says, work out angle Z. Give reasons for your answer. Okay, so we are going to work it out BOC, which is the other angle in our isosceles triangle. So that's going to be 110 degrees, because two lots of 35 and two 35s. And that's the missing angle in the triangle. And we're using part A. Okay. Then we want angle BDC, and that's going to equal 55 degrees, and we'll write our reasoning down here in the because bit. And the reason is the angle at the circumference is half the angle at the centre when we're in the same segment. And they are in the same segment. Funny enough, the same segment is this bit here. That's the segment, so the lines are going from the same point at either end of that segment. Okay. Question 17a, we've got write x plus x squared plus 8x plus 3 in the form x plus a all squared minus b. It wants us to write it in completed square form. So for that, we have the coefficient of x, that's going to be our a. At the moment it's got plus 3, and then we are going to square this and take it away. So 4 squared is 16. And then we need to tidy up this bit here. So it's x plus 4 all squared minus 13. We're going to then use this to sketch the graph of y equals x squared plus 8x plus 3. We need to mark on some important points. One is the point where we cross the y-axis, and we take that from our original equation. It's this bit here. The other points that we're going to be able to mark on, given the information that we've been asked to work out, well, it wants the turning point. So that we are going to use this for. And it's going to be when x is minus 4 and when y is minus 13. And then we are going to try and draw a nice smooth quadratic curve. Ooh. Something that looks like a quadratic curve anyway, through the points. Not my best effort. I might rub that out and try again if I was actually in an exam. Just that bit there. Okay, and then question 18. 21 people travelled to a meeting. 12 used a train, 6 used a car, 7 didn't use the train or a car, some used a train and a car. 2 people are chosen at random. From those who used the train, find the probability that both these people used a car as well. So I'm going to use a Venn diagram to help me sort through this. Train, car, obviously anybody outside the circles didn't use the train or the car. There were 7 of them. We know that 12 people used the train and 6 people used the car. Hold on, if we take away the 7 people that didn't use either though, we are left with 14. If we add together the people that used a train or a car, we get 18. That gives us a slight problem. The difference between these though is the number of people who used both. So 18 take away 14 is 4 used both. We can then go back, 12 take away 4 is 8, so there must be 8 people who just used the train, and 6 take away 4 is 2. And the 2 is the people who just used the car. Okay. Now, we wanted the probability, if we picked 2 people who used the train, we want the probability that they also used a car. So we're only interested in the people who travelled by train. So we're going for the probability of using a car given they used the train. And we're going to do that twice. So the first time around we are picking, there are 4 people out of 12 to pick from. And then we also want the probability of car given the train. We haven't replaced the person though, because we can't pick the same person twice. So this time there are only 11 people, and there are only 3 left that could be by car. So we are going to do 4 times 3, which is 12, and 12 times 11, well 12 times 10 is 120, so we want another 12 on top of that, 132. That's our probability. We could simplify it, but we don't need to because it's a probability question. We don't need to worry about simplifying.